Alright, let's take a look at our lesson on graphing quadratics. Before we jump into the graphing, what I'd like to do is to work a bit on the different forms, the vertex form, standard form, writing the equation of a quadratic, a parabola. Just, it's pretty important actually. If we find an equation that's in vertex form, it's way easier for us to graph than if we find one in standard form. And so we're going to talk about how to go back and forth between those two forms and how we can use the information that we get from those equations to graph. So let's take a look first at vertex form. So vertex form, we have y equals, then we have a, x minus h squared plus k. So the axis of symmetry is the equation of the line x equals h, whatever h happens to be. That's the axis of symmetry. And we can actually read the vertex. We can read the vertex right off of this vertex form. It's hk. Okay, so that's pretty good. Then we have standard form, where we're familiar with this. We used, when we were working with quadratic formula, we were using our equations in standard form, so we could read A, B, and C off of them. There's an additional little, I guess like a little formula that identifies how you can find H, another way you can find H. One way you can find H is you can have your equation in standard form and you can read H out of the equation. Another way you can find H is by using this little formula. And remember, H is the x coordinate of the vertex. So let's spend a little bit of time talking about A. So A, let's just kind of highlight it. It's right here and right here. Those are the same A's. If A is positive or greater than 0, positive, it opens up. What I mean by it is the quadratic, the parabola opens up, and the vertex for that particular quadratic is a minimum value. If A is less than 0 or negative, the parabola opens down and its vertex is at maximum value. So those are just good things to know. We'll be using those. It's helpful to know. If I'm getting ready to graph a parabola, how do I know if it opens up or down? It would really be a good thing to know whether it's going to open up or down before I started graphing. So if we want to convert from vertex form to standard form, which is the easiest of the conversions, we just multiply everything out and simplify. And that's fairly easy. If we want to convert from standard form to vertex form, we really have two choices. One choice would be to utilize that procedure we learned a little bit ago about completing the square. We could complete the square to put the equation in vertex form. That's one option for you. Well, let's say that maybe you want a different option, or maybe you don't want to go through completing the square. You do have another option, and that would be to find H, which is right here. Find H, then substitute H in for X into your original equation to find the Y value, which is K, and then you just write it in this form. Once you have H and K, and of course A is the same in both forms, you can just write it out and you don't have to, but now the key with this one, with option number 2, is you would need to know the formula for vertex form. Because if you don't know the formula for vertex form, finding H and K isn't going to do you much good. So in order to utilize method number 2, you would need to have memorized the formula for vertex form. All right, so let's practice just a little bit. Let's go back and forth. We're going to go right here, our first one. So we got our first example. We are in vertex form and we want to go to standard form. That's the easiest one, where you just basically, we're just going to multiply and simplify. So we know, I'm sure we know, that x minus 1 squared means we have to FOIL that. So let's do that. So let's see, we have x squared minus x, which would be minus 2x plus 1 plus 2. So in standard form, we would have x squared minus 2x plus 3. Okay, see that going from vertex form to standard form is pretty easy. All right, so now let's look at writing in standard form. Let me shrink this a little bit so we can get some more room here. Okay, so now we've got, we're in standard form and we want to go to vertex form. Notice, this is A. It's basically going to be either here, well, that's where it's going to be in our vertex form. It's going to be right here. So we could, let's just practice both methods just so you've seen them both. You can choose which one you want to do. It really doesn't matter to me. Let's look at method 1. Method number 1 would be completing the square. All right, so we go through the steps of completing the square. I'm going to move the constant over. I'm going to factor out the negative 2 from the first two terms. So I factor out a negative, remember factoring means dividing. Factor out a negative 2 from negative 2x squared, I get x squared. I factor or divide out a negative 2 from 8 and I get a negative 4x. Okay, so we've got, now we're going to do the completing the square part. So half of 4 is 2, 2 squared is 4. So I'm going to add 4. And what did I really do on this side? Did I really add 4? No, I really subtracted 8. So in order to keep the equation balanced, I need to subtract 8 over here. So we've got y minus 5 equals negative 2 times x minus 2 squared. And to put it in vertex form like they have it listed up here, we would just move the 5 over. So y is negative 2 times x minus 2 squared plus 5. Okay, and there is our first technique, method 1. Now let's practice method 2. So method number 2, what we would do is we would find h. So h is equal to negative, let's see, b is 8 over 2 times a is negative 2. So let's see, what is h? H is negative 8 over negative 4, which is 2. So h is 2. So now that I've found h is 2, I'm going to take that and I'm going to plug it in to my equation for x. So we have y equals negative 2 times, I'm plugging in a 2 for x, 2 squared plus 8 times 2 minus 3. So what is that? 4 times 2, so is that negative 8 plus 16 minus 3, which is 5. Okay. So now that we know what h and k are, we're just going to plug into our formula. So y equals a, we read right out of the equation, which is negative 2, times x minus h was 2, and then plus k, which is plus 5. And you can see, oops, I'm so silly. You can see that they're both the same. It doesn't matter which way you do it, you're going to get the same thing. Okay, so now let's move to our second page and let's get into some graphing. We just have a couple to graph. All right, so they want us to find the vertex, axis of symmetry, y-intercepts and roots. Remember, roots are the same thing as zeros. Is the vertex a max or a min? And graph neatly. Okay, all right, that's cool. We can do that. So our vertex, we can read right out of our equation. This is in vertex form. Notice, so y equals, basically h is 0 here. Right, so h is, I just rewrote it so it would be more clear. The vertex is 0, -3, which I just got by reading it out of the formula. So let's go ahead and let's make this a little bit bigger. So 0, -3, there's my vertex. Since this is going to be going up, since a is positive, a is a positive 1, then my vertex is at a minimum. My axis of symmetry is x equals h, which is 0. My y-intercept, we can see that we're actually on the y-intercept. The y-intercept is at -3. If you didn't remember, let's say we didn't know or we hadn't plotted that. Remember, to get your y-intercept, what would you do? What are all of the x values on the y-axis? They're all 0, right? So we would plug in a 0 for x to get our y-intercept, which is basically the point 0, -3. Okay, good. Our roots, what is a root? A root is, where does it cross the x-axis? So every point on the x-axis has a y value of 0. So we could say 0 equals x squared minus 3. So I'm just going to move the 3 over. We square root both sides, and we get x is plus or minus root 3. Okay, so we're graphing, so we don't have to be real accurate. Root 3, let's see, root 3 is between root 1 and root 4. So root 1 is 1, and root 4 is 2. So root 3 is somewhere between 1 and 2. So let's just estimate, just somewhere in there. And so we can finish drawing our graph. And so you can, the roots are points, so we can write them as square root of 3, 0, negative square root of 3, 0. So let's see, did we do everything? We've got our roots, we've got our y-intercept, we've got our axis of symmetry. Now please note, axis of symmetry is an equation of a line. Okay, you don't just write 0 there. That doesn't mean anything. It could be y equals 0, x equals 0. Axis of symmetry is the equation of the line, and for these types of parabolas, it's always x equals h. All right, good. We're looking good. So here, let's look at this one. Now it's not the formula is not in vertex form, so we would use one of those techniques for putting it in vertex form. And we did practice that already. For just time's sake, I'm going to go ahead and write the vertex form of this. So regardless of whether you do method 1 or method 2, this is what you should get when you're done. Okay, so we can read our vertex out of our formula. So it's 2, 5. So let's plot that. 2, 1, 2, 3, 4, 5. Okay. We see that a is less than 0, so that means this particular parabola is going to open down, so therefore its vertex is at a maximum. The axis of symmetry is, x equals h, which is 2, so we got that, y-intercept is when x is 0. So y equals -2 times 0 squared plus 8 times 0 minus 3. So it's at -3. So 0, -3. So let's plot that. 1, 2, 3 right here. Okay, great. Now we know that our parabolas are perfectly symmetrical So my axis of symmetry, I'll just kind of draw axis of symmetry in. We know that if I have a point 2 spaces to the left, I'm going to have one 2 spaces to the right. And now I can draw my parabola without a problem. Okay. And so the last thing that I need to do is find the roots. Let's think about what techniques we can use to find the roots. So let's just kind of write them up here. So what can I do to find the roots or solutions? Okay, so I could do quadratic formula. I could do quadratic formula. I could do factoring. I could do completing the square. So those are all options open to me. I certainly would prefer factoring because that's really the fastest, but this particular quadratic does not factor. So what I'm going to do is, since I already have completed the square, I already have that form, I'm going to plug in a 0 for the y in my formula. Okay, and then I'm going to solve. So I would subtract 5 from both sides, divide by -2, and then I would square root both sides. So x minus 2 is plus or minus the square root of 5/2. So x would equal, I'm going to move the 2 over, 2 plus or minus the square root of 5/2. Okay. I don't require you to rationalize, but if you wanted to rationalize, you would multiply this by √2 over √2. So another version of how this would look would be the square root of 10 over 2. Either one of those is fine for me. All right, great, and that finishes out our lesson.